Subagent isolation, the architectural answer to context rot. Playlist 4, Episode 4. From Playlist 3, by 35 minutes into a long agent session, every agent's success rate drops. Lost in the middle, attention dilution, distractor interference. The widget.tsx story, instructions drowned by accumulated tool output. That episode left a question unanswered. If a long session is the worst case, what's the structural fix? Not better prompts, not a bigger model, not a bigger window. The fix is to never let context accumulate in the first place. Here's the failure mode. One agent, one session. Minute 0, clean context, just your prompt and the tool list. Minute 10, files read, tool outputs accumulating. Minute 25, significantly larger mixed reasoning, accumulated noise. Minute 40, the context is enormous, packed, accuracy drops. The same model sharp at minute 0 is now drowning in its own history. The architecture itself is the problem. Said clearly, one agent, one growing context, one accumulating problem. The longer the session, the worse the agent gets, regardless of which model you use. Part 2, the structural fix, isolation not optimization. Now watch what subagent isolation does. The parent stays at the top with a clean, focused context. When it needs noisy work, read 3 files, run the tests, search the codebase, it doesn't do that work itself. It spawns a subagent. Each subagent gets its own fresh context window, its own scoped prompt, its own tool access. It does the noisy work, reads reasons, tries, fails, succeeds. All of that stays inside its own window. Then it returns one summary, clean, focused. This is the architectural pivot, fresh window per task, noisy work isolated, one clean return. The parent's context never grows from the subagent's intermediate work. Context rot by design can't accumulate the way it does in one long session. Map this back to Playlist 3. Lost in the middle? Doesn't apply. Each subagent's context is small enough there is no middle. Attention dilution? Doesn't apply. Each context is focused and sparse. Distractor interference? Doesn't apply. The subagent only sees what's relevant. The 3 failure modes that compound in a long session are structurally absent in a well-designed subagent run. That's not optimization, that's elimination. Be honest about the trade-offs. Subagents help with multi-file work that parallelizes, noisy exploration that would clutter the parent, and tasks whose intermediate work isn't useful upstream. Real numbers: 50 to 70% faster on multi-file work. One team cut Claude code from $480 a month to $128, 73%, with subagent discipline, plus caching, plus tiering. Hold the picture. One long agent session, context accumulates, rot compounds, by 35 minutes the wheels come off. Supervisor with subagents, each gets a fresh window, does noisy work in isolation, returns one clean answer. The architecture is the difference. Same models, same tools, wildly different reliability. Practical rule: reach for subagents when the task is multi-file, when the work scopes cleanly into a summary, and when the parent doesn't need to watch the reasoning. Stay in the main conversation when you're iterating quickly, when the work needs back and forth, when context is small enough that rot isn't a real threat. The production shape in 2026: supervisor on top, subagents handling specialized work, MCP wiring tools, A2A coordinating other agents. Remember 3 things. Context rot is structural, and the fix is isolation, not optimization. Subagent architecture means a parent spawns child agents with fresh, scoped windows that handle the noise and return one clean summary, and the trade-offs are real. Used well, 50 to 70% faster on multi-file work. Used badly, 3 times the bill. Used with judgment, the structural answer to the 35-minute cliff. Fresh window per task, one clean return, rot can't accumulate. Next episode, agent observability. Subscribe.